Hello student, let us understand what is meant by modulus of a complex number. Let Z is a complex number represented by A plus IB. Then its modulus is represented as mod of Z and its value is under root of A square plus B square. Note that modulus is always positive number. Let us find the modulus of a complex number. Let it be Z1 and it is 4 plus 3i. So let us find the modulus of a complex number 4 plus 3i. This is Z1. So its modulus will be equal to mod of Z1 and it will be equal to under root of 4 square plus 3 square. The square of a real part and square of imaginary part. So it is 16 plus 9 and mod of Z1 that is equal to modulus will be equal to under root of 25, but the answer will be the 5, the positive 5. Now let us understand what is meant by argument of a complex number. Argument of a complex number is an angle, and if the complex number is again a plus ib, then the argument of a complex number which is an angle theta, then that theta is nothing but tan inverse of b upon a. It is tan inverse of b upon a. That is the imaginary part divided by real part. Let us solve a question. Let us find the argument of a complex. Let z1 a complex number, or let us consider the complex number z2 as 1 plus I root 3, 1 plus I root 3. Then its argument, it is written as arg and complex number is z2. So arg of z2, it will be equal to tan inverse of root 3 by 1. So we have to think about an angle whose tan ratio is 3, root 3, and it will be 60 degree, that is pi by 3. Note that argument is also known as the amplitude of a complex number. So amplitude and argument refers to the same concept, and it is actually the angle, some angle. What is that angle? That we will understand when we represent a complex number in a Argand plane. With the knowledge of modulus and amplitude, or modulus and what is called the argument, that is angle, now we are ready to represent a complex number in a xy plane, a special xy plane, which is also known as Argand plane. Now how is the Argand plane? Suppose I want to represent z is equal to a plus ib in a Argand plane, and let us visualize the Argand plane. It is actually consists of a x-axis and a y-axis, like a Cartesian plane. X-axis is also known as real axis and y-axis is known as imaginary axis. So it is a real axis and it is the imaginary axis. And here A, actually we will represent the z as a point on this Argand plane. This spatial plane is known as Argand plane, and here z will be represented as a point like this. It is A and this is B, and this point will be A comma B. and the length of this, suppose this is z, and this length from origin to this point is actually the z, the what is called the modulus. So if I represent this point as P point whose coordinates are a comma b, and this is the origin, then OP represents the modulus of z, which is a plus ib, and this angle made by this OP ray or OP segment with in anticlockwise direction with positive x-axis is known as argument or modulus, amplitude of a complex number. So I hope the concept of Argand plane is also cleared. Now the same complex number can also be represented in terms of the modulus and argument. Now if we know the modulus and argument, and if we know the Argand plane, then the same complex number can be represented in the polar form. Now the polar form is actually the modulus and into cos theta plus I sin theta. What is the meaning? The same complex number which is represented as a plus ib, whose modulus is mod of z, can be represented as mod of z cos theta plus mod of z, that is modulus of z sin theta, and it is a imaginary part. This is imaginary and this is the real part. This representation of complex number as z cos theta, modulus z cos theta plus I modulus z sin theta is known as the polar form. And if we write only modulus and the angle like this, then they are known as polar coordinates. So there are various forms. This is the standard form, this is the polar form, and these are the polar coordinates. Polar form and polar coordinates, we can represent a complex number only when we know its modulus and its argument. Argument is also known as amplitude. Thank you, student.